Lesson 3. Energy Resources. Reading Guide. Key Concepts. What are non-renewable energy resources? What are renewable energy resources? Why is it important to conserve energy? Vocabulary. Non-renewable energy resource. Fossil fuel. Renewable energy resource. Inexhaustible energy resource. Inquiry. Extracting energy? Where does the electrical energy come from when you turn on the lights in your home? The answer to that question depends on where you live. Different energy resources are used in different parts of the United States. Sources of energy. Every day, you use many forms of energy in many ways. According to the law of conservation of energy, energy cannot be created or destroyed. Energy can only change form. Where does all the energy that you use come from? Almost all the energy you use can be traced back to the sun, as shown in Figure 10. For example, the chemical energy in the food you eat originally came from the sun. The energy in fuels, such as gasoline, coal, and wood, also came from the sun. In addition, a small amount of energy that reaches Earth's surface comes from inside Earth. However, the amount of energy that comes from the sun each day is about 5,000 times greater than the amount of energy that comes from inside Earth. Electric power plants. Most of the energy you use every day does not come directly from the sun. Instead, much of the energy you use every day is in the form of electric energy. Most of the electric energy you use comes from electric power plants. An electric power plant transforms the energy in an energy source into electric energy. There are three main energy sources used in power plants. One source of energy comes from burning fuels, such as coal. The power plant shown in Figure 11 uses coal as an energy source. Nuclear power plants use the nuclear energy contained in uranium. Hydroelectric power plants convert the kinetic energy in falling water into electric energy. Number 1. Coal contains chemical energy. Number 2. Burning coal changes chemical energy into thermal energy that heats water, producing steam. Number 3. Steam spins a turbine, changing thermal energy into mechanical energy. Number 4. The turbine spins a generator, changing mechanical energy into electric energy. Non-renewable energy resources. The coal that a power plant burns is an example of a non-renewable energy resource. A non-renewable energy resource is an energy resource that is available in limited amounts or that is used faster than it is replaced in nature. Fossil fuels. The most commonly used non-renewable energy resources are fossil fuels. Fossil fuels are the remains of ancient organisms that can be burned as an energy source. Fossil fuels take millions of years to form. They are being used up much faster than they form. Three types of fossil fuels are coal, natural gas, and petroleum. Key concept check. Why are fossil fuels considered a non-renewable energy resource? The formation of fossil fuels. The processes that formed fossil fuels began at Earth's surface. Petroleum and natural gas formed from microscopic ocean organisms that died and sank to the ocean floor, as shown in Figure 12. These organisms were gradually buried under layers of sediment, sand and mud, and rock. Over many millions of years, increasing temperature and pressure from the weight of the sediment and rock layers changed the dead organisms into petroleum and natural gas. Coal formed on land from plants that died millions of years ago and were buried under thick layers of sediment and rock. Using fossil fuels. Fossil fuels formed from organisms that changed radiant energy from the sun to chemical potential energy. The chemical potential energy stored in fossil fuels changes to thermal energy when fossil fuels burn. Using petroleum. Gasoline, fuel oil, diesel, and kerosene are made from petroleum. These fuels are burned mainly to power cars, trucks, and planes and to heat buildings. Petroleum is also used as a raw material in making plastics and other materials. Using coal. Electric power plants burn about 90% of the coal used in the United States. Coal is also used to directly heat buildings and to produce steel and concrete. Burning coal produces more pollutants than burning other fossil fuels. In some cases, these pollutants react with water vapor in the air and create acid rain. Acid rain can harm organisms such as trees and fish. Reading check. What percentage of the coal used in the United States is burned in electric power plants? Using natural gas. About half of all homes in the United States use natural gas for heating. Electric power plants burn about 30% of the natural gas used in the United States. Burning natural gas produces less pollution than burning other fossil fuels. Fossil fuels and global warming. Burning fossil fuels releases carbon dioxide gas into Earth's atmosphere. Carbon dioxide is one of the gases that helps keep Earth's surface warm. However, over the past 100 years, Earth's surface has warmed by about 0.7 degrees Celsius. Some of this warming is due to the increasing amount of carbon dioxide produced by burning fossil fuels. Nuclear energy. Humans can also transform the nuclear energy from uranium nuclei into thermal energy. Uranium is found in certain minerals, but significant amounts of uranium are no longer being formed inside Earth. As a result, nuclear energy from uranium is a non-renewable energy resource. Reading check. Why is nuclear energy released from uranium nuclei considered a non-renewable energy resource? Nuclear power plants. In a nuclear power plant, breaking apart uranium nuclei transforms nuclear energy into thermal energy. As shown in Figure 13, this thermal energy changes water into the steam that spins the turbine. Unlike fossil fuel power plants, a nuclear plant does not release pollutants into the air. However, a nuclear power plant does produce harmful nuclear waste. Number 1. Radioactive nuclei are broken apart, changing nuclear energy into thermal energy. Number 2. Thermal energy heats water, producing steam. Number 3. Steam spins a turbine, changing thermal energy into mechanical energy. Number 4. The turbine spins a generator, changing mechanical energy into electric energy. Storing nuclear waste. Nuclear waste contains radioactive materials that can damage living things. Some of these materials remain radioactive for thousands of years. Almost all nuclear waste in the United States is currently stored at the nuclear power plants where this waste is produced. Renewable energy resources. Fossil fuels and uranium are being used up faster than they are being replaced. However, there are other energy resources that are not being used up. A renewable energy resource is an energy resource that is replaced as fast as, or faster than, it is used. Key concept check. Contrast renewable and non-renewable energy resources. Hydroelectric power plants. The most widely used renewable energy resource is falling water. To generate electric energy from falling water, a dam is built across a river, forming a reservoir. As water falls through tunnels in the dam, the water's potential energy transforms into kinetic energy. Figure 14 shows how a hydroelectric power plant transforms the kinetic energy in falling water into electric energy. Hydroelectric power plants do not emit pollutants. However, in some places, dams can disturb the life cycle of some wildlife, such as fish. Number 1. The water behind the dam has potential energy. Number 2. Potential energy changes to kinetic energy as water flows downhill. Number 3. The kinetic energy of the flowing water spins a turbine. Number 4. The turbine spins a generator, changing kinetic energy into electric energy. Solar energy. Another renewable energy source is radiant energy from the sun, solar energy. Because the sun will produce energy for billions of years, solar energy is also an inexhaustible energy resource. An inexhaustible energy resource is an energy resource that cannot be used up. Less than about 0.1% of the energy used in the United States comes directly from the sun. Solar energy is converted directly into electric energy by solar cells. Solar cells contain materials that transform radiant energy into electric energy when sunlight strikes the solar cell. Solar cells can be placed on the roof of a building to provide electric energy, as shown in Figure 15. Wind energy. Wind energy is another inexhaustible energy resource. Modern wind turbines, such as the ones in Figure 16, convert the kinetic energy in wind into electric energy. Wind spins a propeller that is connected to an electric generator. Wind turbines produce no pollution. However, wind turbines are practical only in regions where the average wind speed is more than about 5 meters per second. Also, many wind turbines covering a large area are needed to obtain as much electric energy as one fossil fuel burning power plant. Biomass. People have often burned materials such as wood, dried peat moss, and manure to stay warm and cook food. These materials come from plants and animals and are called biomass. Because plant and animal materials can be replaced as fast as they are used, biomass is a renewable energy resource. Some biomass is converted into fuels that can be burned in the engines of cars and other vehicles. Fuels made from biomass are often called biofuels. Using biofuels in vehicles can reduce the use of gasoline and make the supply of petroleum last longer. Geothermal energy. Thermal energy from inside Earth is called geothermal energy. This energy comes from the decay of radioactive nuclei deep inside Earth. In some places, geothermal energy produces underground pockets of hot water and steam. These pockets are called geothermal reservoirs. In a few places, wells can be drilled to reach geothermal reservoirs. Figure 17 shows a geothermal power plant. The hot water and steam in the geothermal reservoir are piped to the surface, where they spin a turbine attached to an electric generator. Hot water from a geothermal reservoir forces its way through a pipe to the surface where it turns to steam. The steam turns a turbine connected to an electric generator. The steam cools in the cooling towers and condenses into water. The water is pumped back down into the geothermal reservoir. Conserving energy resources. The graph in Figure 18 shows that fossil fuels provide about 85% of the energy used in the United States. Because fossil fuels are a non-renewable energy resource, the supply decreases as they are used. Because the supply of fossil fuels is decreasing, there could be shortages of fossil fuels in the future. Conserving energy is one way to reduce the rate at which all energy resources are used. Conserving energy means to avoid wasting energy. For example, turning off the lights when no one is in a room is a way to conserve energy. Key concept check. How does conserving energy affect the rate at which energy resources are used? In the future, energy resources besides fossil fuels might become more widely used. However, as Table 2 on the next page shows, all energy resources have advantages and disadvantages. Comparing advantages and disadvantages will help determine which energy resources are used in the future. Advantages and disadvantages of energy resources. Non-renewable energy resources. Fossil fuels. Advantages: easy to transport, widely available, relatively inexpensive. Fossil fuel power plants are relatively inexpensive to operate. Disadvantages: drilling and surface mining may damage land and wildlife habitats. Oil spills and leaks can harm wildlife. Burning fossil fuels can produce air pollution. Burning fossil fuels produces carbon dioxide that can cause global warming. Nuclear energy. Advantages: nuclear power plants are relatively inexpensive to operate. Does not produce air pollution. Disadvantages: produces radioactive waste that is difficult to store. Accidents can result in dangerous leaks of radiation. Nuclear power plants are relatively expensive to build. Renewable energy resources. Hydroelectric. Advantages: does not pollute the air or water. Hydroelectric power plants are relatively inexpensive to operate. Disadvantages: dams damage wildlife habitats. Dams can affect water quality and reduce the flow of water downstream. Droughts can affect hydroelectric power plants. Solar. Advantages: does not pollute the air or water. Theoretically inexhaustible supply. Disadvantages: the amount of solar energy that reaches Earth's surface varies, depending on the location, time of day, season, and weather conditions. A large area is needed to collect enough solar energy for a solar power plant to be viable. Wind. Advantages: does not pollute the air or water. Can be used in isolated areas where electricity is unavailable. Disadvantages: wind turbines can be noisy. Can be disruptive to wildlife. Only generates electricity when the wind is blowing. Geothermal. Advantages: does not pollute the air. Geothermal power plants are relatively inexpensive to operate. Disadvantages: geothermal reservoirs are located primarily in the western United States, Alaska, and Hawaii. Some geothermal plants produce solid wastes that require careful disposal. Biomass. Advantages: biofuels could replace petroleum fuels in most vehicles. Disadvantages: energy from fossil fuels is used to grow biomass. Some farmland is used to grow biomass instead of food crops. Burning some biomass produces pollutants, such as smoke,